Hello everyone, welcome back to this Grasshopper tutorial series. In this part of the video, we will be focusing on building out our randomized base mesh, which will be the waveform that we will use to intersect the points. So first I'll explain what we're going to do. So if I pick out my pen, first off, what we'll try to do is from the short side, we will make a line that is slightly larger than the total width because we want to make sure that Grasshopper will intersect to the surface, and we don't want to leave it to chance where it might intersect on the side and then things could fail. So we're going to make it a little bit bigger. And then from that point on, what we will do is we will introduce a set of points. Let's say we're going to start with 4. So 2, 2, and 2. And what these points will do is it will, from these points on, we will make a curve. And that curve will look something like, for example, maybe the first one will be looking like that. The second one will be somewhat randomized, although I'm not really drawing it in a randomized manner. And then we have the third one that looks like this. And lastly, we have the fourth that could something like that. By chance, I'm drawing it. Okay, let's draw the last one totally different. Something like this. What we'll do then is from these 4 curves, we will loft them together, which will be our base mesh, base surface actually. But we'll turn that into a mesh because that will be easier and fast to work with. So that will be method number 1, which is the randomized version. And then after that, I will explain how we can do the manual one, manual method, which will offer us the maximum flexibility in order for us to customize how our wave should look like. Because if it's random, we have little control over how it will turn out to be. We can only manipulate a certain small aspect of those parameters. So first off, we'll focus on this one. So let me get that out of the way and then we'll start. So first off, we will take our plane, the base plane, which I can make it from here. The base plane will be from this one. Actually, we can also take it from this. So maybe that's what I will do. I'll keep this like this. Now we'll call this base plane. And then I'll immediately add this to the group, and I'll link that out. And then now what I can do is deconstruct this plane to get the original plane that we want. So like that. And now we have to draw that line. A very easy one is to just do it as ZL. We know the origin is there. Now we need to figure out which one of these do we want. So if I turn that base plane on, we know that the red axis usually indicates or actually always indicates the x-axis. So we know that that's the direction we want to go. So that will go here. And as for the length, well, the length just so happens to be the width. So we can actually make a number. Yeah, we'll make this a number. We'll take this one here. Now, if you've forgotten, you can directly name this without having to type this in. It will take the name from the input. When you're dragging, press 1 time Alt. It will turn into a red arrow. If you plug that in, it will also take the name of whatever you're plugging into. Could save you a few milliseconds. So we're going to pick that in here. We'll move that here, and we'll give that, oops, we'll give that the length. So now we have our line. Now, as I mentioned just now, we want to make this a little bit bigger. So what we're going to do is we are just going to, there are 2 ways. We can actually extend the curve, or we can just scale the curve. Both works just as fine. So we want to connect this one here. And then we need a middle point because the C is a scale point. So what we can do now is if we do, I think in Rhino 7 there is a center curve command. I first saw that and then I was quite surprised that there was actually a center curve. Now I can't really find it. Or is in middle? Yeah, curve middle. I think this is a new component, but I'm not sure. But if you don't have it, because you have a different version of Rhino or Grasshopper, sorry, you can just do evaluate curve, plug this one in, we parameterize it, give it a 0.5 parameter, which will be the middle point. Or you can actually do center one of these, I think. Oh wait, that one doesn't work for a curve. So you do have to do this. Or you can just do the extend curve. Just put two numbers here and make sure that this one is set to line, which also works. Since I have this one already, I'm just going to use this one instead. And now I'm just going to make a scaling factor of 1.1. As long as it's bigger than 1, it should work. So I can close that. So this is my extended curve. Now what I wanted to do here is to make those 4 points, right? So I'm going to do a divide curve. Divide curve, this one. So I'm going to divide this curve. And the number of division I want is, we can start with 4. We'll see how that works out. I think by now I should probably get rid of these points. Because I'm divided by 3 sections, actually I want this to be 4 so that what this gives me. So what I'm going to do is actually right click on the n, x minus 1. So that when I have 4 here, I get 4 points instead of 4 individual section between the points. So I'm just going to call this interpolated curves. Yeah. All right, we'll call it like that. That should be fine. And now that we have these curves, actually, can we turn that back on a little bit? Now we have these curves. We want these curves to be oriented differently so that we can scale the curve that I just drew in the vertical axis, which is the z-axis. So we need to make new plane that's based on this plane. So basically this plane should be rotated like basically, rotated by 90 degrees is what I'm trying to say. One way to do that is we can orient. Well, actually rotate the plane. Let me see if I can find it. Oops. Or actually we can make a new plane, construct plane. Yeah, that should also do. For the origin points, what we're going to do is we will take the division points. So those points. So these need to be orientated. So it takes an x, y, z. We can take one of these. We just need to know which one to take. Now, if I quickly highlight that and hide this one, so we know we want one of the axes to be the green one. That should stay. The red axis should flip to the z-axis. So what that means is I can actually take the z and plug it into the y. I can turn this on, turn that one off. Now that one is okay, but I want the y, the green one, or the red one actually. So I'm just going to take the x and see how this one goes. Oh, that's not the y one, it seems. But if you take the y, that will rotate the plane the way we want it to. Now we can actually switch this around, but it doesn't really matter. It just means that we need a different variable because pointing upwards is positive. But we'll see how we can deal with that. Now, with this one being constructed, these planes, we can draw curves on these planes. We can actually make SDL lines here. But since the SDL line takes a direction, we can take a direction from here, but I prefer that we deconstruct this again so that we always know that we are working with the right plane. Because if something changes here and along the way things change and things get messy and we forget where it takes the direction and why it takes from there. So this just makes a little bit more sense. Okay. So do we want to the red axis, which is the x? Now for the length, this is something that we have to decide for ourselves, like how much do you want to animate, right? First and foremost, we want to animate, make it into, let's say, in sections, right? We want to animate this whole length as one unit and then times that unit. So we need to go back into our grid points. We want to take the points on the long side. So I'm going to make a new output. So I might have done that too fast. So if you've forgotten, drag, holding left click, one tap Alt, it will take the name of the input. So I want that, but I also want the stepping, this number, which is the distance between the points. So I'm gonna make another data. So I'm gonna, all right, this doesn't have a name, so I'm just gonna call this, what am I gonna call this? Distance between, in between distance. Distance between the points. If you want to write that also in it to make it more explicit. So we can copy these. We'll run these up like that. We'll put them here. We'll sort them out later and see which one, how we can sort those. So now if we do a multiplication of these, we get the length. Now if we plug that into here, we get the length that covers our entire, well, a little bit more because we're actually plus 1 of here because we're counting this one times another step. But this is okay. So we have this distance cover for one block. Now, what we can decide is we can extend this how we want to. So for example, if we say wave, let's make a slider. Let's say we want to extend it by 5 times. And then we call this wave total length. Actually, it's length multiplier. I'm not a fan of making very long names, but we'll see what we can give it later on. So this is a, we'll multiply this. So we'll just do multiplication. You multiply by that, which will give us the number that we have here multiplied by 5. Put that to length. So this could be the length, the total length of our wave. So now we can adjust how much do we want to give this. Okay. Now with that being said, we can actually now work on these lines. So I can actually disable the starting points for now. I can also disable these. I don't need to see that. I also don't need to see all this. So now that we have the line, we can do the same thing again, which will be to divide the line. Now, at this point, we are sort of allowed to control the random frequency. You'll see in a minute what I mean by random frequency. So if we were to divide this curve by a set amount of points, let's say we start with 10 and we'll go up to 30 perhaps. So let's start with 10. because of this, now we have a tree, or actually 4 branches, and each branch will have 11 points, right? Now what this will do, we can actually work with this. We will need to have a jitter. I'm not sure if I should use a jitter or not, or I should just use the randomizer. Actually, I should use the randomizer. What we'll do is we'll randomize each point individually, right? And then we can control that with C. So the amount of lanes we have, we'll have to apply this to the C so that we get each lane will be a different seed and therefore will be different from from its neighbors. So to start, obviously we'll need to move these points. So we need to start with some statistics. So we need to rely on how many we have here. I rather rely on the output here instead of the input that we put in here, which is doable. I prefer to work this in a more linear way so that we know that the data is always right and it's actually easier to grasp. So if we put as tree statistics in here, you can get the path name, which not really used unless we find a user, but we're interested in the amount of elements within each tree, each branch, and how many branches we have, right? Both of those numbers are actually here. So whether you take it from those 2 sliders and have to draw all the lines, or you take it from here, it's going to be the same thing. So first, let's tackle the randomizer. So this is the domain of 0 to 1. Of course, we're going to have a lot more than that. So we're going to domain construct. We're going to construct a new domain for ourselves. Let's say the domain will start from, let's start with a number, let's say 500. And the ending domain could be, let's put this one here first. We'll have to see how it works. So 500 to 1000. So we will get numbers between that domain, right? But only one number at the moment. So we need to fill this with the list that we've got here. So if you put in the L to the N, what you will see is you get 4 lists of random numbers, but they're the same number because we only have one seed. Now to change that, one easy way is to do a series. Now remember, the C dictates how many branches we have. So from the series, what we want to do is I just want to say I want 4 numbers, and we can apply that here. Now all the numbers are different. You can change the starting point, it will just randomize it, so it doesn't really do that much. And now what you will get is we have a grafted list, or each list containing 11 items, and we have the points with also 11 items, 4 branches with 11 items each. Now we can actually put this in here. We might have to check if we want to simplify something. Oh, we do have to put this to negative because we want them to go down and not up. So once we do that, we get our randomized point, although they aren't really randomized because the domain is still quite low. But if I were to turn this to, you can see that this is actually looking at this side, that they're all different. To visualize this more, what I'm going to do is actually quickly do a interpolated line. So take this one, it will be interpolated. Let me disable also the original line. So you can see there's a small bump in there already. Oops. And let's loft this also. Now for the loft to work, we do need to flatten it. Now we can actually take this off. Actually, let's leave this on. Now we can actually come in here and then we can mess with the domain. Let's take the maximum to 5,000 and we can start to see how it will be randomized. And then we can also introduce a little bit more to create more frequency if that is what we want. So that is what we're going to call this too. So we're going to call this, I don't know, random frequency. So obviously the more number you have, the more of this wave you will get. But that also depends on what the total length is, because if you stretch that, you get more subtle waves again. So let's leave this at 15. We'll leave it like this. And for this, for the domain, we want to have something that makes sense. Now you might wonder why 500? The reason for 500 is if you open up the original points, which are here, is what we wanted to make sure is that the points that dictates that will ultimately result in this surface that you see is never going to be higher than the maximum, the ceiling, right? That makes no sense. Hence, I've introduced a small number for you to control. And this is also a number that you can also control to see, to dictate how far down should the element be. Now, if you remember in the animation, you can see my the video that I rendered out, that strings are rather long, and that has to do with the domain start. So maybe that's something that we can put in here. We can put maybe here initial string length. So obviously this will be, let's say this is about that. Let's say it will start at 3,500 millimeters, so 3.5 mils from the ceiling. Now you can see that doesn't make sense for us to control these. Well, what I want to do is actually put in addition here. I want the initial value to plus whatever delta we want, right? And that will give us the second component for our domain. So I'm going to call this delta height. What this value will dictate now is, if you look at it from the side, okay, the highest point and the lowest point will be within this number. So if I say I want the wave to be a little bit gentler, I can say, okay, 2,500. So now they will just follow this, which to me makes a little bit more sense and gives us a little bit more control, right? Okay, now I can clear that. I don't need this anymore. What we now need is we need to mesh our surface. Now you can just do, you could just do this one, but as you can see, it's not really, well, it's not really uniform, and it's actually quite ugly. So what we're going to do is we're going to try different meshing, and we can find that in, I have to find it myself, mesh surface. Yeah, okay, let's do this. Mesh surface. Oh, this one. Now what this will do, it will give us a little bit control to how many division we want in the U direction and the V direction. So for example, if the surface goes to the S, and now if I, let's say, introduced, let's say 15 on here, it will create 15 of these strokes, right? The same applies to the V. So obviously in that direction, you will want to have a little bit more. Now, at this point, this is okay. But let's say you change one of these. I mean, the number we supply is still okay, but we don't want to be adjusting these two values as often, right? We want this to auto-calculate for us, depending on how frequent we want this and so forth. So what we're going to do is we are actually going to make a small formula that calculate this for us. And one way to do that is, well, just to make use of how many points we have on the initial grid, this one. We can use the in-between distance to calculate that for us. And what I mean by that is, you'll see in a minute, is we will have to do an evaluate command. Well, actually, let's use the expression editor so you can see what's going on. So what I want is I want to have the width, which now really doesn't change a lot. You could take the width from this curve. Either you take it from that curve or you take it from the 7,000. It doesn't really matter as much. We could also just take the short side number here, but I don't really want too much inputs and outputs here. So I'll just take it from this one and I'll recalculate that again because I have the in-between distance, all right, which will be this one. So if I say, double click here, if I say x divided by y, which will, let me set up a panel, which will give us 15. Let me introduce one more. I don't think this will, we will need this, but let's apply this to, I guess that one is for that one. Oh, we haven't included. So right now it's 15 is when this gets wider, it will just take the average or similar in between distance, but we want a little bit finer mesh. So that's why we introduced this 2. And what we're going to do here is say whatever number that is, right, times 2, which will give us a little bit finer. Now the same thing is going to happen to the, we can delete that, to the V direction. Obviously, we're not going to be using this, but we will use the total length that we have now, which we have made, I think it's, yeah, it's this one. So we'll say, let me plug this to the panel so we can see. So we all have 380. Let's see how that looks like. I mean, this looks fine enough. So if we introduce, times 0 doesn't exist, so we should actually be careful with that. Well, that's weird. Times 0 should give us 0, but this is not giving us a 0. Oh, because I have entered a 2 instead of z. All right. Because times 0 means 0. So let's say 1. So if you want fine mesh, I probably should limit this for the sake of safety. So, oof, I can already feel that this is way too fine for what we want to achieve. I mean, you could probably get away with 1, but I'll leave it at 2 since it's a mesh. It's still quite light. And we can actually now get rid of that. And now we don't have to worry about all this. So it will dynamically adjust this for us. Okay. So that's going to be the mesh. So I'm just going to quickly create an output for this. You here, and I'm going to call you base mesh. So we can just click that. For reference later on, what we want to do is we want to have a look at what we are dealing with here. Instead of having the red line here, what we want to do is just create only the edges so that we can see through it. You know, we're going to give it a little bit of custom coloring. I don't think there's anything in E3, only E1 and 2. No, I wasn't pressing, I was pressing caps lock. All right, and then we'll just supply with a a color that's not too damaging for our eyes. I was hoping for something like that, something very subtle so we can see what's going on. All right, I think this, now we can actually come in here and say this is hidden, and this is also hidden, and this is also hidden. So now we can do this, hide that, hide everything else, copy that one here, base mesh. And then we can actually group this now. So now we have our base mesh. Before I end this part of the tutorial, what I wanted to do is also include the other method of making the base mesh, which will require a little bit more manual work. So we're just going to put some points in here. We'll make some layers. We'll stick with four curves, just as this one, because I think that's plenty enough for us. So with the power of editing, or maybe I can just copy it from the other file. So before that, I want to make 4 layers first. So I'm just going to click on new layer. We'll say lane 1. We'll duplicate that. Oops. We'll call this lane 2, lane 3, and lane 4. So now, hopefully I can copy this from my other file and paste. Oh, I'm probably going to be copying also the name along with it. But here they are, the points. Obviously, this is not as long as the other one, but that's okay. Here's my gumball. So I just need to make sure that they're roughly the same. As you can see, they're not evenly spaced, but that's okay. I can use the gumball to do that for me. So if you want it longer, you can obviously add more points to it. So, but first off, what I wanted to do is let me quickly hide this one so I know what I'm working with. Actually, why are there 2 points on top of each other there? Oh, I think I might have, oh yeah, I accidentally right click so that we pasted those points. What I want to do is sort this in these lanes instead of what I had before. So if I can just, so let's say select objects, change the object to that port, to that, and then we'll change this one here, and we'll change this one here. Now this process can be a little bit automated in the sense that we can just throw everything in one layer and have the have Grasshopper figure out for us which is what. But I just want to show you this manual work and how what kind of flexibility we're looking at. So we'll just give it a different color in order for us to visually and quickly be able to identify it. So that'll be blue, RGB. I want something that's not too bright, actually, something like that, yeah. And the last one, oof, maybe purple. Yeah. Okay, as you can see, I already moved some of these points because they were moved in the previous model. So what we're going to do is we're going to reference these points using a geometry pipeline. And we'll call this lane 01. It will only reference point, so that will only reference that point. And we can just copy these a few times. Lane 2, lane 3, and 4. Oops. Now, needless to say, if you want to add points, you have to make sure that each of these pipelines consist of the same amount of points in order for us to work. First, let me test this out. So if I were to interpolate a curve, yeah, as I thought, the points are not sorted like they should. Let me quickly see how they're orientated. So if I quickly bring up a sort points, so this one, if I hover over it, it's sorted by first the X and then the Y and then the Z. Okay, this coincidentally, this suits us pretty well. So there is my sort point, because it will always sort by Y value first. And if I look from the top, none of the points are too close to each other, will give us errors. So we just have to copy this a few times. Or we can actually just put this all into a entwine. Maybe maybe that's even cleaner. So maybe we'll do that. We'll do that. So let's put in an entwine. Put this here, add one more branch. You go there, you go there. Now we can do this. This is a lot cleaner. And from this point on, it's basically the same thing. So we can actually just come here. Do we want to use that? Let's see how it goes. Let's see how it works. So let's use that and see how that goes. So let's say U will be hidden. And let's see what the mesh looks like. Ooh, very detailed. Okay. Well, that's okay. That's okay. So as you can see, what this method will give us is, let's say, for example, we want to have a dip here. We can just move our points. This will give you ultimate flexibility in how you want your wave to look like. The only thing here is, like I said, it requires a little bit more manual work, but this is the only, or actually the fastest way. So you can actually move this a little bit, extend this a little bit more. As you can see, the points don't necessarily need to be at equal distance from each other. So that's one way where you can actually play around with it a little bit. So we can actually do this, make your own wave, basically. So the same thing what we do for the model selector, we're going to do for this one too. So we're going to call this maybe base mesh selector or something like that. First, we'll have to select it between here. So we're just going to make it toggle. I can't write. Something's wrong. I need more coffee. There we go. Toggle. And then we'll do filter gate. So what are we going to call this? Use, manual base mesh. If it's false, means no, we don't want to. So if it's false, it takes that. But if it's true, it takes that. Where are we gonna put this? Actually, you know what? We're gonna put this there. We do have to move this a little bit because there we go. Then this one can actually, you know what? We'll just include the whole lot in there. There we go. Here. And then we can enable that. So now it's saying, wait, are we using? Oh yeah, we are. So if we're not, we do this. If we are, we do that. By using this method though, you do have to make sure that you save your Rhino file along with it, because those data are there. And you have to make sure that the length of your points roughly matches with the randomized ones. So that's almost like twice as long. So you might have to add more points to it. Actually, I'm going to show you how to add more points. So the quickest way will be to just select maybe the last row or the last two row and just use the gumball and Alt. As you can see the plus sign on my cursor, and then you let go. There we go. So this is how you can extend your curve. The other way why what you have to look out for actually is if you were to in anyhow where is it, rotate the base mesh, you might have to rotate your manual points along with it, unless you put something in here that takes in that rotation into account. So that could be a nice exercise if you want to know how to do that. But if you get stuck, just put your question in the comment section. I'll try to come back in here and see if there's a easy way to do that. All right, so let's make sure that we are not using the manual base mesh. Okay, right. So now we have a base mesh, right? We have our grid points, and we have our model. So now we can finally come in here and combine these three elements and start animating. And we'll do that in the next video.